Consider the statement, the rate of change of some quantity y is directly proportional to y. This is like saying that the more money that you have, the faster it will grow. Or the more you scratch an insect bite, the worse it will get. Or the more addicted someone is to a substance, the more the addiction will grow. And so we can translate this statement, the rate of change of some quantity y is directly proportional to y, in this way. The rate of change of y is directly proportional to y. And this statement that you're seeing, dy dt equals ky, is an example of something that is related to either exponential growth or decay, where k is the growth or decay factor, whatever the case may be. Now let's notice what happens. If we were to try to solve this differential equation, we would first separate the variables. First I'm going to multiply both sides by dt and divide both sides by y. So 1 over y dy is equal to k dt. And recall that k is just some constant of variation. If we were to integrate both sides of this equation, which is always our second step, what we'll end up with is the natural log of the absolute value of y is equal to k times t plus some constant c. Now, in order to solve this for y, we're basically going to convert this to exponential form. Y, the absolute value of y, must be equal to e to the kt plus c power. Another way that some people explain this is we put both things were exponents on e. That undid the natural log process. Now e, since it's a positive number, to any power is always positive, so we can drop the absolute value sign. Y must equal e to the power of kt plus c. Now we're simply just using exponent properties. When we're adding two exponents, in this case kt plus c, that's equivalent to the product of two things that have the same base. Right? So that's just an exponent property. And notice that e to a constant is just some other constant. Right? So e to the c power is just some other constant. So I'm going to rewrite this as y equals that constant, c, times e to the kt. So anything of the form, the rate of change of some quantity y is directly proportional to y, will always become, when you solve it, the form y equals c times e to the kt. And other textbooks put it this way: instead of using c, they call it y naught times e to the kt. Notice that when in our first form, y equals c e to the kt, if t equals 0, then y equals c. So the reason that some textbooks prefer y naught is because that's the value you get when t is 0, or it's the initial value, the starting amount that's either growing or decaying. It's important that you know this translation backwards and forwards. Now, you don't have to memorize it if you're comfortable simply solving it, but this will always happen for everything of this specific form. And this form comes up quite a bit. So now let's look at a few examples.